All right, so let's use flower power and go backwards now. Real simple. Look at this number. This is an index of 2. There's the exponent. Remember, that's your root, that's your power. So check it out, right? So flower power tells us there's a little plant, there's the roots down below, the root goes below, the power goes above. Now, the neat thing about this is you can actually reduce this. You can reduce this from 4 over 2 to 2 over 1. So your power is actually 2 out of this. So basically what you've got here is you got 25 to the power of 2. If you don't believe me, watch this. The square root of 25 to the power of 4. Watch. The square root of 25 gives you 5. 5 to the power of 4 is 625. Now, what's the square of 25? I'll prove it. Watch. The square of 25, 25 squared, is 625. Thank you very much. So in fact, being able to put it in this form could actually help you save several steps. Let's do this one. Might be a little tougher now. We want the square root of 4.2 cubed. Okay, so 4.2, the square root, that's the root, goes on the bottom. There's the power, goes on the top. Okay, and you can put that directly into your calculator, right? Your calculator says 4.2 to the power of 3 over 2. 3 divided by 2. There it is. Give me a number. Bang, 8.6. Good enough. Move on with life. Isn't that awesome? Okay, look at this one. Same kind of idea. You got the square root of 5 over 2, which means that's 5 over 2 to the power to the root. Okay, power is 5, root is 4. Throw it in your calculator. Let's see what we got. Okay, so brackets, 5 divided by 2, bracket. Remember, all fractions should go in a bracket. The powers, there might be a little of exception to that. 5 divided by 4, hit enter. Now, you're going to get this kind of wonderful decimal place. Now, that looks ugly, but you know what? I bet you can put that into fractional form. So answer into fractional form. Let's see what it says. No, doesn't go into fractional form. Guess what? Leave it as 3.14. Ooh, close to pi. Interesting. Okay, that's all you can do with that one. Look at the last one again. There's the power. There's the root. Okay, away we go. So minus 2.5 to the power over the root. And just again, throw that into your calculator. Remember, with negatives, it's really, really important to have the bracket on it. So negative 2.5, okay, bracket to the power of 3 divided by 2. There it is. Oh, sorry, divided by 5. Boom. There we go. And we get negative 1.73. Negative 1.73, which is kind of cool. Now, can we use this as a practical application kind of question? Well, yes, we can. I've got a great question from your textbook. It says, use the following formula to estimate the brain mass of each animal, which is kind of interesting. This stands for the brain mass. This stands for the body mass. And what this particular study did is they did a correlation between the size of the animal and the size of its brain, which is kind of neat. And guess what? It becomes a exponential or radical function. So look at this. It says a moose has a body mass of 512 kilograms. So what's its brain size? Well, that's 0.01. Its mass is 512 to the exponent 2/3. Now, the problem with this is remember, you got to use BEDMAS, okay? So brackets exponents first. So bringing up your calculator, hitting clear, okay? There's your 512. Has to be to an exponent first, which is 2 divided by 3. There's your exponent, giving you that wonderful number, and then you multiply this by your 0.01, and you find out that the moose's brain mass works out to be 0.64, and it would be kilograms. There you go. That's how you do a practical application. Look at the cat now. Meow. Okay, look at the cat now. The brain mass is 0.01. The mass of the cat is about 5 kilograms, and 2/3 is, of course, the power. Same thing as before. Get your calculator going here. This is 5 to the power of 2/3. 2 divided by 3. Boom. Multiply that by 0.01. And now you know, look at that small brain mass of 0.029, which tells you why your cat gives you attitude. Okay, all you cat lovers, send your hate mail to idon'tcare.com.